Hey guys, it's the last week of summer. I know you are sad about going back to school because everybody usually is, but it's kind of exciting because you get to see your friends again, and now you get to know that you're going into math ahead of the other children. If for no other reason, because you have been practicing math and they have been watching TV and playing video games, okay? So it's kind of exciting. Now, this week it's a topic called the Pythagorean theorem, and this really is one of the math things that everybody seems to know. It's pretty cool. And what I have noticed about it is that my keyboard won't go away. Okay, there we go. What I've noticed about this Pythagorean theorem, guys, is that even people that are out of high school, like if you ask your parents, a lot of them are going to remember this. And what this is used for is finding the sides of a right triangle. Now, most of you remember what a right triangle is just from, like, you know, I don't know, elementary school. This yellow, like, look at this picture. This yellow thing in the middle is the right triangle. And I'm gonna put a little right angle there and color that in because I think that's probably how you remember it. But notice the legs are labeled with an A and a B, and the hypotenuse is labeled with a C. And all that this means is this is sort of a picture for why the formula I'm going to show you works. The formula is a squared plus b squared equals c squared. So I'm going to write under this, one of the legs squared plus one of the legs squared is always equal to the hypotenuse squared. And that's just what A, B, and C represent, okay? So this picture over here is showing you that. So notice they put over here, like they have an area of, if you count these boxes, there's 9 boxes here. And so I'm just going to put a 9. There's 9 boxes here. There are 16 boxes down here. And this red one, if we counted up all the boxes, there are 25. So notice the area on each of these sides here, 9 squared plus 16 squared. I'm sorry, not squared. It's already squared. 9 plus 16 equals 25, right? So do y'all see that 9 plus that 16 equals that 25. And so what this is saying is that if these are a leg that's already been squared plus a leg that's already been squared equals a hypotenuse that's already been squared, you can work backwards from this to find out how long each side is right here, okay? And the way that I would do that is just ask myself, what number, if I square it, equals 9? So what number times itself equals 9? Oh, well, that would be 3, okay? And what number times itself equals 16? 4. And what number times itself equals 25? 5, right? So this, if we counted boxes, we got this equation from the Pythagorean, and then we work back into this. And so if you compare this to what's right here, what this is telling me is that one of the legs is 3, so this little leg is 3, this little leg is 4, and the hypotenuse is 5. So we know how long everything is. And by the way, that set of 3, 4, and 5, those lengths of sides, is a very popular Pythagorean triangle. It's actually called a Pythagorean triple. This is one of those that most people memorize. And it doesn't always go like, oh, the numbers are always in order. No, it's not like that. It's not like, oh, there's a 6, 7, 8 or a 7, 8, 9 triangle. It's not like that. This one works. There's another famous one that works that people usually memorize, and that's 5, 12, 13. And all that means is if one of the sides is 5 and the other side is 12, then the hypotenuse has to be 13. That's what that means. So that's another famous one you're going to see. Okay, so what good... Let's go on to where this is just a little bit about why it works. And if you don't care, that's fine. Don't get stressed out about it. We just need to know how to use it. Okay? So what good does it do me? We kind of already answered that. You can find missing parts of triangles, okay? Find missing sides of triangles. Now, The key here is they do need to be right triangles, and I think everybody should know the difference between a right triangle and a non-right triangle. You have to have that 90-degree angle, so keep that in mind, okay? Now, the parts of a triangle, just as a refresher, just kind of like I said above, this is your right angle. Across from the right angle is the hypotenuse. And the two other parts or sides of the triangle are usually called legs. So that's a leg, and that's a leg, and that's the hypotenuse. So what I want you to do is whenever you see a picture, I want you to set it up before you math it out. And what I mean by that is no matter how the triangle is turned, okay, so if it's all turned a weird, wacky way like this one, I would love for you to look at the picture that somebody gives you and actually label it first, okay? So I would look for the 90-degree angle and then go, okay, well, across from that, the longest side is the hypotenuse. And if you want to abbreviate, that's fine, but that's the hypotenuse, which means these two are legs. And that's important because if you look above on the formula, the A, B, and C have to go in a specific place, okay? The C is always the hypotenuse. So I'm going to put a big fat C right there. And you might want to make a note right here. C always, either say the hypotenuse or the longest side, because the hypotenuse is the longest side, okay? So I'm going to say always hypotenuse. C, always the hypotenuse. Now A and B, you can put them wherever they want because A and B are just legs. So I don't know, eeny, meeny, miny, mo. I'm just going to put A up here and B down there. It doesn't really matter, okay? So set it up first. That way when it's time to use the formula, it will be easy to use. So let's actually do an example. Given a picture to find the hypotenuse. So if somebody gives you something like this, and they give you that maybe that's 6 and that's 3, and then they put a big fat question mark there on the hypotenuse. We have to be able to use our formula to do this problem. So before we start, let's do what I said right back here, and let's label everybody, okay? So if this is my right angle, you're going to label this as the hypotenuse or the C, okay? So label them both if you're not lazy. And these are my legs. This is a leg and this is a leg. So put the A and the B on them. It doesn't matter which one's A or B. The only thing that matters is that C just went on the hypotenuse. And now what we'll do is we'll plug these numbers into the Pythagorean theorem. Okay, so a squared plus b squared equals c squared. Now let's actually stick those numbers into the right spot. So what did I put for a? Well, a over here on my picture is the 6. So I'm going to put a, my pen's not working, I'm going to put a 6 squared right there. The plus sign I recopy. Now what was the b? The b is 3. So I'll put a 3 squared. And then it equals the c. Well, the c is what we don't know. So you could either leave it a c squared or you could put a question mark squared, whatever you want to do, x, you know, I'm going to call it a c though. And now we try to solve. So let's math out what we know how to math out. Okay, what is 6 squared? 6 times 6 is 36. 3 times 3 is 9. So that's what we know so far. Notice I'm just recopying as I go, kind of like good algebra skills here. Just recopy so you don't get confused in your work. Now what's 36 plus 9? Well, 36 plus 9 is 45, I believe, and that's equal to c squared. Okay, so basically what we're down to is that some number squared is equal to 45. And that's hard to figure out because if you start doing all your numbers, like you know that 6 times 6 is 36, we know that 7 times 7 is 49, but this is a number that's in between those, and so that's going to be hard to figure out. And in algebra, what you're going to learn at some point this year is that if you ever need to undo this and work backwards, you do what's called a square root. So the idea is that if this is not a whole number and you can't figure it out, you're supposed to take the square root of 45. And that is a number we don't know, so I would just leave it alone. Now, your teacher may tell you something later next year, and that's fine. Do whatever they tell you, but my students would probably leave it alone as the square root of 45, or they would actually pick up a calculator and type that in, because that button is definitely on your calculator, and you can get a decimal for it. Now, I don't have a calculator on me right now, but it's a 6 point something. It's a 6 point something. So if you pick up the calculator and type it in, you'll get 6 point something as a decimal. But what that is that is the length of your hypotenuse. Okay? So that's how it works. Hopefully this part's not too screwy, but maybe after we do a couple more, you'll be okay. So let's try another one. And, you know, as always, if you want to try these before me, feel free to hit pause and actually give it a shot, and then push play to see if you did it right, okay? So given a picture to find a leg. So this is an example where maybe you're given that this is 13 and that's 10 and that this is unknown. This is our, we don't know what this is, okay? So like I said, feel free to hit pause if you want to try it yourself, but my first step is going to be to label it. So here's my right angle, so the thing across from it is the hypotenuse, and the hypotenuse is always the C, okay? A and B could go in either place. I'm just going to do that like I did on the last one. And then I'm going to immediately start to plug into this formula and see if I can figure out the missing side, okay? So now let's plug in numbers for all three of these, okay? All right, what am I plugging in? Okay, so my A in this problem is the question mark. So since I don't have a number to plug in, I'm just going to recopy A squared. Recopy the plus sign. Okay, what is the B in the problem? Well, the B that I chose was this leg, which is 10. And that's equal to C, which is 13, squared. And now I do whatever math I can, okay? So I'm going to recopy the A squared. Now what is 10 squared? Well, 10 squared is 10 times 10. What is 13 squared? 13 times 13, okay? And now it's weird. It looks really weird. It's like some number plus 100 equals 169. Well, the goal here is to figure out this missing thing, so you really need to get it by itself. And the way you get it by itself is you need to make this 100 disappear. So to make that 100 disappear, I'm going to subtract a 100 so that it goes away. But remember from earlier this summer, whatever you do to one side, you have to do to the other. So I'm going to subtract 100 from both sides. So when I bring this down, it's an A squared. These two go away, right? 100 minus 100 is 0. I'm going to recopy the equal sign, and now what's 169 minus 100? Well, that should be 69, okay? So when you look at this, you now have to find some number times itself that equals 69. Well, let's think about our numbers. What's 8 times 8? Okay, that's 64, so that's close. What about 9 times 9? Well, that's 81. So this is not going to be a perfect whole number, which means it's like the last problem that we did. So if you can't get a whole number in your head, then what you'll have to do is take the square root of the number on the other side. And you can leave it like this, okay? Or same thing, if you have a calculator, feel free to type it in. You're going to get 8 point something. I don't know what the calculator is going to tell you, but it's 8 point something. So feel free to do either way, either a decimal or leaving it as a radical. All right, cool. Now we're going to skip this box, so put a big fat X in that. Okay, that's not something you're going to have to do this year. Also on your next page, I'm going to show you how to do the first one. But the second one is not probably going to happen to you for a while, so feel free to cross that out. But on this one, let's go ahead and do this application problem, because word problems are a big deal, right? Okay. Application, if you have a 12-foot ladder propped up against a wall, okay, I'm going to go ahead and stop and start drawing my picture, okay? I always draw a picture. So I've got a wall, so we'll call this the wall. Okay, and there's a ladder stacked against it. So go ahead and draw yourself a nice little ladder stacked up against it. I'm not a great drawer, as you're about to find out. Okay, that's close enough. Okay, so, and then I'll make the grass, we'll be on the ground, so we'll make it like green for grass. Okay, so here's my picture. A ladder's propped up against a wall, and it tells me the ladder is 12 feet long. So I'm going to go ahead and label the ladder with a 12. Okay, so it's asking how far out from the wall is the base of the ladder. So it wants to know how far is from here to here. So this is my question mark, okay? If the top of the ladder hits the wall 8 feet from the floor. So the top, where the ladder hits the wall to the floor is 8. So what this picture's supposed to, you're supposed to notice that this looks like a right triangle, and the little right angle would be there at the corner. And then you can go and do just like we did on the other problems. Let's start by labeling A, B, and C. Okay, which one has to be the C? Well, the C has to be across from this fella, so I'm going to call that the C. Now, A and B, remember those can go anywhere you want them to go. So I'll just put an A here and a B here. It doesn't really matter. And now we'll start our Pythagorean theorem. And you know something else that's kind of cool, just to prove how important this formula is, then that everybody knows it. I don't know if you've ever seen The Wizard of Oz. If you haven't, you've kind of been neglected as a child, honestly. But if you want to go watch The Wizard of Oz, there is a scene where the Scarecrow gets his diploma from the Wizard of Oz, and it's kind of cool because the minute the wizard hands him the piece of paper, he like spits out this big math definition. And if you go watch that scene again, you could probably even YouTube the scene. YouTube Scarecrow Gets a Brain, and he will say the math definition for the Pythagorean theorem, and it's really cool. Now when you see that, you'll understand it because you've seen it today. Yeehaw. All right, so let's keep going. I digress. What did I put for A? Well, for A is the number 8 right up there, okay? What is the B? Well, the B is the question mark. So if B is the question mark, we're just going to leave it as a B. And then what was my C? My C was a 12. All right, cool. So now let's math it out. What's 8 times 8? 64. The B, I just recopy it because I have no idea what that is. And what's 12 times 12? 144. Okay, cool. So this is very much like the last problem. We have to get this by itself so that we can try to figure it out. So we need the 64 to disappear. To make the 64 disappear, I'm going to subtract it from both sides. So now that's a 0. And I bring down my b squared. And what is 144 minus 64? Ugh. Okay, I'm going to have to do old school subtraction. 4 minus 4 is 0. 14, that's an 80. Okay, cool. So is there anything times itself that equals 80? Well, 9 times 9 is 81, but not quite 80. So this is another one of those that we can't do in our head, so we're just going to write it like that. The decimal for that is going to be like an 8.9, something like that. It'll be really close to 9, but it won't be exactly 9. Okay, cool. So you could look in the calculator for that. All right, so give those homework problems a try. If you come to the tutorial with me, then we can look at this one right here, but don't sweat it. You know, if you want to try it, if you're good at graphing and you want to graph these points and give it a try, go for it, because yeah, that's going to be pretty awesome, actually, if you know how to do that. But don't worry about it if not. And good luck, and we will see you guys in the next video.